Welcome back to the All-in-One Certification video series. I'm Mike Redmond, Master Trainer, here to guide you through your successful journey of becoming a Security Plus certified professional. We're going to walk through a variety of subjects like access control and encryption, all the way down to network security and hardening the OSs. In this section, we're going to define environmental controls, describe the components of redundancy planning, list disaster recovery procedures, and describe incident response procedures. So, what is business continuity? It's the organization's ability to maintain operations after a disruptive event, like a power outage or a hurricane or tsunami. Business continuity planning and testing steps include identifying the exposures to threat, creating preventative and recovery procedures, and testing those procedures to determine if they are sufficient to protect the organization's assets. It's also important to develop a succession plan. It's simply who is going to be in charge and take over if key leaders are missing or incapacitated. These elements will be part of your BIA, or your business impact analysis. It analyzes the most important business functions and quantifies the impact of their loss to that organization. It will identify the threats through the risk assessment portion and determines the impact of those threats if they are realized. You should develop a questionnaire. You'll hand these out to managers and key leaders as to their focus for their portion of business operations. It will discuss different disaster scenarios. The BIA interview form helps organize information obtained through the interview process. Some of the interview contents should be things such as the name of each individual business unit, employees, numbers of employees, whether they're full or part-time, and what their functions are. Are there any dependencies, either parent or child dependencies, that particular unit relies on? Technology recovery that they find critical to their operation. What are the quantitative and qualitative impacts to disruption of the business unit? Recovery strategies that may need to be put in place and looked at for full operation or partial operation, and then the amount of time needed to fully recover once a disaster is realized. Disaster recovery is simply a subset of continuity planning, also known as contingency planning. You will find in your disaster recovery, you need to identify the mean time to restore. This measures the average time needed to reestablish key and essential services. Core components of a disaster recovery activity is to create, implement, and test disaster recovery plans. Each disaster recovery plan is simply a written document with a detailed process of restoring resources. You should update it regularly, and it should provide sufficient detail to give anyone step-by-step procedures and how to recover from any perceived or actual disaster. You will need to break out your different disaster recovery levels. Generally, you'll see them as level 1, 2, or 3, and identify the core impact areas of each level of risk that is realized. The most common features you should find in any disaster recovery plan is a definition of the plan purpose and its scope, the definition of a recovery team and what those responsibilities are, the list of risks and procedures and safeguards that reduce the overall risk to the organization, an outline of emergent procedures and detailed restoration procedures. It is key to understand that a disaster recovery plan must be adaptable. It must be flexible. Not every disaster is going to happen or be realized in the exact same way, and your plan should not be so rigid as to not allow for that type of flexibility. If a planned response is not working properly, technology should be able to be rolled back to a good starting point. And it is also extremely important that once you have the plan, that you test the plan often. When testing the plan, you're looking for some key metrics, like testing the efficiency of interdepartmental planning and coordination, and testing the current DRP procedures, making sure that they're not deviating from the plan during the exercise itself, because you want to take note of what might need to be changed later, and then determine the response strengths and weaknesses against the plan. Next, let's talk about redundancy and fault tolerance. When we are looking for how to achieve fault tolerance or achieve a level of redundancy, what we're looking for are single points of failure, any single component or entity that will disable an entire system if it no longer functions. You want to remove any identified single point of failure. This is the primary mechanism to ensure business continuity. During the BIA process, the organization will identify tolerable downtime, whether they're looking for 90% uptime or up to 6 nines, you'll see it identified uptime. It completely depends on the organization's appetite for risk. Redundancy and fault tolerance is the next way to address single points of failure. With redundancy planning, we're looking at applying these to servers, storage, networks, powers, and alternate sites themselves. Remembering servers, for instance, play a key role in network infrastructure. Failure can have significant business impact. Some organizations actually will stockpile parts for servers or have whole redundant servers ready and waiting in case of failure. Others take a more proactive approach and will do server clustering. There are two types of server clusters, asymmetric and symmetric. Asymmetric servers perform no function except to be ready if needed. However, with symmetric servers, all servers do useful work. If one server fails, remaining servers take on the failed server's workload. You often see this used for web and media and VPN servers. Next is your hard drives. Often these are the first components to fail. What you're looking for is the mean time to failure. This measures the average time until a component fails and must be replaced. To combat hard drive failure, we employ RAIDs, or redundant array of independent devices. It uses multiple hard disk drives to increase reliability and performance. The Security Plus examination expects you to know and be able to identify several different types of RAID configurations, starting with RAID level 0, which is a striped disk array, but it provides no fault tolerance. If one drive fails, all the data on that drive is lost. Next, we have RAID 1, which provides mirroring. Disk mirroring is used to connect multiple drives to the same disk controller card. The primary drive can fail and data will not be lost. With RAID 1, you can choose to disk duplex. It's just a variation of RAID level 1. This time, however, you're going to use separate cards for each disk. This protects against controller card failures. Next, you have RAID 5. This is probably the most common and most popular RAID configuration. A series of independent disks with distributed parity. Data stored on one drive and its parity information stored on another drive. RAID 5 provides the highest level of fault tolerance. Next, we have redundant networks. These may be necessary due to the critical nature of connectivity today. Essentially, it's a network in waiting. It waits in the background during normal operations and then launches automatically in the event of any type of disaster. Many organizations contract, for instance, with a second internet service provider as a backup to the primary service. Next are UPSs, or uninterruptible power supplies. They maintain power to the equipment in the event of an interruption. You have a couple choices, either offline UPSs, which are the least expensive, which begin supplying power quickly when the primary power is disrupted, or online UPSs. They're always running off its battery while main power runs the battery charger. It's not affected by dips or sags in the voltage and can serve as a surge protector. They can also communicate with the network operating system to ensure an orderly shutdown occurs. Or you can opt for a backup generator, usually powered by diesel, natural gas, or propane. Next, we'll talk about the different types of backup sites and locations. It's a site necessary if, for instance, a flood or a hurricane or other major disaster happens to your primary building. Again, you have several options to choose from, starting with the hot site. The hot site is a duplicate of the original production site. It has all the needed equipment there, usually run by a commercial disaster recovery service. Data backups can be moved quickly to the hot site-like location. Or you have the cold site. It provides basic office space. However, it takes longer to resume full operations. It is a lot less expensive than the hot site, but it really all depends, again, on the organization's tolerance for risk and how long can they be down before the organization and the business is unrecoverable. There is a middle ground, however, and that would be the warm site. The warm site has all the equipment already installed, but no active internet or telecommunications facilities. It is, again, less expensive than the hot site. However, the time to turn on connections and install backups can be half a day or more. Looking at your backups, you have to look at them for what they are. They are an essential element to any disaster recovery plan. The questions to ask when creating a data backup plan is what information should be backed up, how often should it be backed up, and where should the backup be stored? To perform your backup, you'll need to determine frequency. There are different types of backups to deal with, either a full backup, differential backup, or incremental backup. It's important for you to know and understand the differences between these three types of backups. A full backup is the starting point for all backups. The full backup is absolutely needed for data recovery. The differential backup backups any data that has been changed since the last full backup. And the incremental backup backs up any data that has changed since the last full backup or last incremental backup. To determine the frequency of your data backup plan, you'll need to identify two key ports of data, both the recovery point objective, or the RPO, and the recovery time objective, the RTO. The RPO is the maximum length of time an organization can tolerate between backups, where the RTO is the length of time it will take to recover backed up data. When selecting your backup plan, that's really only half the battle. Now you need to decide your backup medium, starting with magnetic tapes. They've been around for over 40 years, can store up to 800 gigs of data and relatively inexpensive. However, the disadvantages of magnetic tape backups are they're fairly slow and prone to failure. You can opt for a disk-to-disk backup. Better for RPO and RTO than magnetic tape, but may be subject to failure or data corruption like any other disk. Next, you have disk-to-disk-to-tape, which is just a hybrid of the first two, or continuous data protection. It maintains a historical record of all changes made to the data. It performs data backups that can be restored in a rather immediate way. Next, when dealing with contingency planning and disaster planning, you need to look at your environmental controls. These are methods to prevent disruption through environmental controlling, such as fire protection, proper shielding, and configuring HVAC systems. So for fire suppression, remember there are just four key elements when it comes to fire and for a fire to occur. Fuel or combustible material, oxygen to sustain that combustion, heat to raise the material to an ignition temperature, and then the chemical reaction. That's the fire itself. The Security Plus examination expects you to know and recognize which type of fire extinguisher to use for which type of fire. Class A, B, C, D, and Ks. Next is EMI shielding. Remembering attackers could pick up electromagnetic fields and read data. One of the ways to protect against this type of attack is a Faraday cage. It's a metal enclosure that prevents entry or escape of electromagnetic fields. It's often used for testing in electronic labs. And your HVAC system. Data centers, for instance, have very special cooling requirements. More cooling necessary due to large numbers of systems generating heat in a confined area. Heating, ventilating, and air conditioning, otherwise known as HVAC systems, maintain that temperature and relative humidity as required for those levels. You will need to arrange your data center in what's known as a hot-cold aisle. This is simply by lining your servers up in alternating rows with cold air intakes facing one direction and hot air exhausts facing the other direction. Next, we'll talk about your incident response procedures. An incident is simply when an unauthorized incident occurs, a response is required. Those incident response procedures can include using basic forensic procedures to mitigate the overall damage. So what is forensics? Simply applying science to legal questions or analyzing evidence. You have computer forensics that uses technology to search for computer evidence of a crime. Why is that important? Well, the amount of digital evidence to go through can be a daunting task. Increased scrutiny by the legal profession as to the reliability of computer evidence is always prevalent. The higher level of computer skill by criminals makes it harder and harder to find evidence of actions after they occur. Basic forensic procedures, it's a four-step process. Secure the crime scene, collect the evidence, establish a chain of custody, and then examine the evidence, starting with securing the crime scene. The ultimate goal is to preserve evidence. Damage control steps are taken to minimize the loss of evidence. You'll need to document everything in the physical surrounding. Take photographs of everything before anything is touched. And the team must take custody of the entire computer, not just bits and pieces or parts, and then they will conduct basic interviews. Next, when preserving evidence, the computer forensic team captures all volatile data first, being sure to capture the most volatile to the least volatile. You'll want to make sure that there is a bit-for-bit copy or a mirror image backup of the hard drive. This meets all modern evidence standards. The order of volatility would be, for instance, the register cache or any peripheral memory first, then the RAM, and then any network state, and then, of course, the running processes. This is the proper sequence of collecting volatile data. Next, you need to ensure and maintain an established chain of custody. It's simply who has control of what and when. Then, and only then, will you begin to examine evidence. Windows page files, for instance, can be a valuable investigative lead.
There you have it. Pretty simple, right? I told you it was. I know, it seems like a lot of information all at once, but remember, study hard. lots of practice questions, and you will succeed. You will become a Security Plus certified professional. I'll see you next time.